Hello, this is Dr. Bob Brown. In this lesson 9.3, we're going to cover the law of cosines, which is some more trigonometric theory which helps us complete our capability to solve all triangle problems. So in this lesson, we're going to cover solving side-angle-side triangles and then solving side-side-side triangles where we have all the sides and need to find the other three angles. And then we're going to look at solving some applied problems. So we're going to do case 3 and case 4 that we talked about in the previous lesson. And here is the law of cosines that says that c squared is equal to a squared plus b squared minus 2ab cosine of c. And this helps us solve a problem where angle C is not a right triangle. So we know angle C, and we want to find side C, and we know A and B. And it's basically a modification of the Pythagorean theorem, which if C were 90 degrees, cosine of C would be 0, and we would just have the Pythagorean theorem. And this particular theorem works for all sides A, B, and C. So you can write them, it's always going to be that B squared is equal to the sum of the other two sides squared, minus 2 times the product of the other two sides times the cosine of the angle between them. And similarly, a squared is equal to b squared plus c squared minus 2bc cosine of a. Now notice that we can solve equation 1 for 2ab cosine of c. 2ab cosine of c, bring that over here, is equal to a squared plus b squared minus c squared. And so cosine of c is equal to a squared plus b squared minus c squared divided by 2ab. And this is just another form of equation 1, which allows you to solve for an angle C if you know the other sides. Now, here's your law of cosines, and here is the other version that you can use to solve for angles. And I would know all of these formulas too, and have all these ready when you're trying to solve any of the various triangle problems. Illustrates the fact that a triangle can be have no obtuse angles, in which all of them are acute. The other example is where one of the angle C is obtuse, and just illustrates that if you take the point here, using our knowledge of a non-unit circle with a radius of A, that this point would be a cosine of C, and the y value would be a sine of C. And this would also work if angle C were obtuse. this just makes the x value negative, because the cosine of an angle more than 180 degrees, more than 90 degrees is negative. This is the law of cosines in words. It says that the square on one side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. Knowing this will probably help you be sure that you're writing the equation down correctly. So let's solve a triangle problem that's side angle side using the law of cosines. We got a triangle here on the right. We know A, we know B, and we know the included angle. It is not a 90 degree angle, so we can't use the law, the Pythagorean theorem. We have to use the law of cosines. So writing this down, c squared is a squared plus b squared minus 2ab cosine of c. Plugging in for a equal 2 and b equal 3, and c is 60 degrees. Plugging in, we get that c is equal to the square root of 7. Now notice we want to find angles A and angles B. And so we use the other form that says that cosine of A is b squared plus c squared minus a squared over 2bc. Now plugging in for b equal 3 and c equals square root of 7, squaring them. A is 2, so a squared is 4. Divided by 2bc, we get that cosine of A is equal to 2 square roots of 7 over 7. And I'm going to do this on the calculator. Turn the calculator on, and we're going to take inverse cosine of 2 square roots of 7 divided by 7, close parentheses. And I'm going to check. I think I'm still in degree mode. But sure enough, I am in degree mode, and I get 40.9 degrees for that angle. Notice that you can solve for B using the other version, cosine of B equal a squared plus c squared minus little b squared divided by 2ac. Plug in, and you get that cosine of b is the square root of 7 over 14, and that b is equal to inverse cosine of the square root of 7 over 14, which is 79.1 degrees. Notice that if we add up all the angles, 79.1 plus 60, which we knew, plus 40.9, we get 180 degrees, which we would expect. Now, suppose you have 3 sides of a triangle. What you would do is use the version of cosine of A, cosine of B, and plug into the formulas. Here we're given A is 4, C is 6, B is 3. Plugging in, we get cosine of A is 29 over 36, and A is equal to inverse cosine of 29 divided by 36. It's about 36.3 degrees to the nearest tenth of a degree. Cosine of B now, use the same kind of formula, is equal to a squared plus c squared minus b squared divided by 2ac. Plugging in, you get cosine of B is 43 divided by 48, and B is the inverse cosine of 43 divided by 48, which is 26.4 degrees. Now that you got two of the angles, you can subtract the sum of those two from 180 and get that C is 117.3 degrees. So that's how you solve a side-side-side triangle. Now we're going to work another problem. Suppose we take off from Naples, Florida in a motorized sailboat going to Key West, which is 150 miles away, and you're maintaining a constant speed of 20 miles per hour, but encounter heavy crosswinds and strong currents. And the crew finds itself after 4 hours that the sailboat is off course by 24 degrees. And we want to answer the question, how far is the sailboat from Key West at this time? Through what angle should the sailboat turn to correct its course? And how much time has been added to the trip because of these winds, assuming that the speed remains at 20 miles per hour. Well, here we are. If you were going at 20 miles per hour for 4 hours, the crew had gone 80 miles, but it had gone 24 degrees off course. And at that point, it wants to turn through a certain angle and head for Key West. Now, Key West is 150 miles from Naples. And so we want to find out X, which is how far the boat is now from Key West after it's gone off course by 80 miles. And we need to find out what that angle is. Now, notice that x squared, which is this side squared, is going to equal 150 squared plus 80 squared minus 2 times the product of the two sides times cosine of the angle between them. And that angle is 24 degrees. So x squared is 6974.91. And x is 83.5. So we determined that the sailboat is just about 84 miles from Key West. Now we want to determine the angle. We would like to find the angle theta, but what we have is a triangle next to it. So let's use the law of cosines, which says that 80 squared plus 84 squared minus 2 times 84 times 80 times cosine of A equal the other side squared. So now we're using the included angle A, which we're looking for. And we get that cosine of A times 13,440 with a minus sign is equal to 9044. Cosine A is thus minus 0.6729, and A then is inverse cosine of minus 0.6729, which is 132.3 degrees. So if A is 132.3 degrees, the angle it should turn would be 180 minus A, which is 47.7 degrees. So the sailboat should turn through an angle of about 48 degrees to correct its course. The total length of the trip now is 80 plus 84 equal 164 miles. So the extra 14 miles will require about 7/10 of an hour, or about 42 minutes to make it up, if the speed is 20 miles per hour. You get that for the distance is equal to rate times the time to make 14 miles up at 20 miles per hour. The time is 0.7 hours. And that is the lesson for today.